Alright, what is up? It's your boy the Canologist, and I'm going to be doing this question here. Divide two integers, medium. Given two integers, dividend and divisor. Divide two integers without using multiplication, division, and mod operator. Okay. The integer should truncate towards 0, which means losing its fractional part. For example, 8345 would be 8, negative 2375 would be negative 2. Return the quotient after dividing dividend by divisor. Assume we're dealing with an environment that you could only store integers with 32-bit signed integers. Okay, so negative 231 to 231 minus 1. For this problem, the quotient is strictly greater than 231 minus 1. Okay. I mean, this question, if we go to the whiteboard, I'm just thinking to us, I'm just spitballing for this. This has a 17% pass rate, so I know a lot of people fucking struggled with this. So, let's see. Like, the way I'm looking at this is basically... It's like this, so 10, and then because you can't use, like, this is the division operator, right? So this is the operator that we can't use, so we can't use this. So we have to go like 3, figure out how many times we can fit this in, so that's 3, right? If we go 10.0, put the decimal up top here, this will be 9, right? 9 minus 10 is thing, 1, and 10. How many times can we fit 3? 3. So it's going to be 9 again, 1, 0. And then what's called, once again, this comes down. This comes down, so 10, 3, 3, 10, 9, this would be 9, 3 times it could fit 1, so like the remainder is always going to be 1, and you can keep going 3 until infinity. It's going to be 3.333, and then what's called 3.333 is approximately equal to 3, because we get rid of the fractional, and then we get 3. So basically we have to create a scenario like this where we have to fit the number in X amount of times and then truncate the decimal. So it says divide two integers without using multiplication, division, and mod. I'm just curious, let's go to Python Playground. I want to see if using int truncates the integer. So let's go a, boom, deletes x equals 8.35. Then I want to go print x, and then print int x. Yeah, so this truncates it. So integer just cuts off the decimal, and then you get what it is. I just want to see if now it goes, if it rounds, if it does auto rounding. What if it's 8.9? Yeah, so this just truncates the decimal to create an integer. So this is one of the parts I gotta do. So first I want to figure out how many times this fits. Well, once we figure out how many times it fits, we have to find a way to shift to looking at fractionals. That's the other part that's tricky. Like, how does it know when to turn it into a thing? Unless you start it as a floating point. Right? So yeah, with that, I'm not completely sure. That's why I gotta think about this a little. And figure it out. Once I just gotta check my messages. Interesting. So yeah, I'm kind of stuck. We're at 7 minutes. Okay, let's ask some probing questions. Let's go and look it up. So how can I do long division in Python? Because what I did on the whiteboard here is long division. It's called long division. It's where you get a number and you see how many times you can fit the divisor into the dividend. And then if I can fit it 3 times, boom. Then I pull down next, then 3 times and 3 times and 3 times, and then it keeps going because this is 10 and this is 3. It's not an even number, so it's gonna keep going forever because there's always gonna be a remainder of 1. Right, so I'm talking at a million miles a minute because I'm trying to get this on ASAP. How do you long divide in Python without using backslash? How to divide without remainders in Python. Will be 1, 2, 3. For example, let's take 10. Let's try and do it on the whiteboard. So let's take 10. Right. And 3. So I want to create some sort of pseudocode. So 3 can fit into 10 3 times. So it would be a while loop. So while, let's say x equals 1. While x is less than the dividend. So x equals x times divisor. So that would be 3 times 1 equals 3, and then it would keep going over and over and over until we hit 12. So while x is less than, it keeps going until it becomes greater than. Once we get out of this loop, I want to go x minus the divisor, because it's 1 over. I want to go back to 1 just before it gets over, right? And then, so for example, this will give me 9 now, because this will be 12 minus 3 is 9. So this will be 9, and 9 is less than 10. So 9 minus 10, because now we know if we go this minus divisor, it's going to be, or if we go 10 modulus thing, we get 1. And then we have to turn it, or we can turn it into a string, add a 0, turn it back into an integer, and then keep doing that. But the fast way, I guess, would be because what I want to do also is get that number. So divisor would be 9. But that doesn't tell you how many times you can fit it. So 3 times 1. Oh, and then we could do a counter. Counter minus 1. So we could go counter, and every time we do this, we can go counter plus 1. That would tell us how many times the divisor fits into how many times the divisor fits into the dividend, right? So 3 fits into 10 3 times, but the counter is going to show 4 because it's going to go 1 over. So that way, when we exit the loop, we just go counter minus 1 to get 3 times, and that would be the truncated value. Actually, I think I could try that. I think that would work without using multiplication. Divide 2 integers without using multiplication, division, and mod operator. I mean, I could also do x equals 0 and just add, because 3 plus 3 plus 3. So let's do it. Let's follow the rules. So let's go x equals 0, and then go plus equals divisor until it goes above, and then I go minus divisor. Yeah, so counter minus 1, and then counter plus 1. Okay, so let's try it. 10 divided by 3 truncated to 3. So what I want to do now is, first I can go while x, so let's make x equals 0. While x is less than dividend, right? I want to go x plus equals divisor. Let's go 3 plus 3 plus 3. And that's what I'm trying to do here. And then I want to also create a counter variable. Counter equals 0. Counter plus equals 1. Counter plus equals 1. So by the time I get in here, it's going to go 3 plus 3 plus 3 plus 3. In order to break this condition for the while loop, it's got to go to 12. Because 9 is going to be just before 10, so the while loop's still going to run one more time, and that means 9 is going to turn to 12, and the counter is going to go from 3 to 4. So we just have to make sure when we get outside the loop, counter minus equals 1. And then return counter. This should work. I'd be so surprised if it does. Should at least finish the first test case. Come on. Come on. Come on. Wow. How? How is divisor -3, bro? How the fuck is this? Okay, case 1, 10. Divisor. Dividend. Counter x. While x is less than dividend. X plus equals divisor. Just gonna keep adding it. Okay, I'll put if x equals, if x equals the dividend, then we return the counter as is. So for example, let's say it is 9. So 3 plus divisor plus 1. Okay, cool. 3 divisor plus 1 equals, okay, cool. 3 Okay, let's just delete these two. I don't know why it's giving me -7. It shouldn't. Counter, counter, counter. Divisor is -3. Why? Why? X equals 0, while x is less than dividend. X plus equals divisor, which would be 3. Right. What's the time? What's the time? 19 minutes. Okay, let's just look it up because I don't get why it's not working. Like logically, it should do exactly what I did with long integer. Oh, divisor cannot equal 0. Okay, that's perfect. And dividend is less than or equal to the thing. Okay, so it's within this. So everything makes sense to me. So I don't get why. So let's go to ChatGPT. And then my code. But you guys get my logic, right? Like it's not the worst thing. Your current code has some logical issues. Negative numbers. Your current number does not handle negative numbers correctly. It assumes both. Oh, dividend divisor are positive. This could be fixed by dealing with the signs separately. You're incrementing the divisor one step at a time, which could be very slow for large values. By using a bit shift method, okay, doubling the divisor until it exceeds the dividend. Okay. I was just trying to do that because it said we couldn't use the multiplication operator. Determine the sign of the result. If the dividend is less than 0, it's not equal to. Okay, so figure out if it's true or false. Dividend is less than 0 is not equal to divisor work with absolute values. Okay, cool. Result, dividend divisor, temp divisor. Okay. XOR to determine whether it's negative. Instead of incrementing divisor each time, we use bit shift to double the divisor and accumulate the result efficiently. This reduces the number of operations. Okay, it's fair. Oh, so bit shift. Okay, let me try that. I just want to try something. Let's try the bit shift method. So let's say this is 3. Temp multiple 1, divisor 1. So yeah, it still does while divisor is less than, because greater than or equal to on this side, all I did was flip it. Same thing. You're doing a multiple, same thing. So all they're doing now is checking times 2 times 2. So 3 times 2 times 2 times 2. Shit, my arms are like cramped from the gym. Like overshot. Okay, but I get what the bit shift is trying to do. Double the divisor while it is less than the dividend. Dividend minus equals temp divisor, result plus equals the multiple. Subtract the largest double divisor and the multiple to result. And add the multiple to result. Okay, so multiple. I'm curious, this is 1, right? So 1, let's say 1. Okay, so it's the powers of 2, because anything where you use the shift bit register is powers of 2. Interesting. Okay. Or 26 minutes. Okay, so let's go through with this now. Fixed knuckle the way I structured it. Handling negative numbers. Okay, handling edge cases. 32-bit -1. Okay, cool. Okay, so first you have to get within that bound, then figure out what is negative or not, and then you do divisor counter, which is the same thing I already did. X plus divisor is less than equal to the dividend. Yeah. And then if negative, you just make it negative. Okay, cool. So it's pretty much the same shit. All it does is handle negative values is what I missed. So go if dividend equals -231 and divisor is -1. Return 231 minus 1. But I could see why there's a 17% pass rate. Because there is a lot of nuance to the question. Then we go dividend divisor. Convert both numbers to positive so it's easier for calculation. Okay, so that way we could just do the straight division first and figure the other shit out after. And then ABS both. X equals 0, counter equals 0. Yep, same shit. X plus divisor is less than or equal to dividend. Same shit, counter plus 1. So it's exactly the same code that I already have. All it does is it takes this and puts it up here so that way we can just check if it's equal to. And then if negative, make it negative. That's what, where's that? Where's the negative handled? If negative, Negative. If any of these is less than 0, negative is true. So you just make counter negative. So if negative, so like for example, all this logic is the exact same. The only thing that I missed was to handle negative divisors, right? So negative numbers. That's why you have to do absolute value for division. But like the logic I had is pretty much the exact same. So counter equals negative counter. That's it, right? It's nothing crazy. And then return within 32-bit signed integer bounds. So max and yeah, you have to return it within the bounds. So, and those bounds are given to you here, strictly greater than or equal to, and if the quotient is less than, return 231. So basically it's saying if it's less than that, return the value. 2 to the 31 minus 1. If it's less than that. And then get the max value between this. Alright, that should work. And we could submit. Wait, what? What is going on? 9-4. Divisor equals. Right now I signed it. So I have to check if it's equal to. Wait, what? What's wrong with this? What is wrong with this? Small corrections. Dividend equals 2 to the power 31, but the dividend value can range between 2 to 31, negative 31. Corrected code. Two to the power 31 minus 1, 2 to the power 31. Oh, negative 2 to the power 31. There. This always happens. Something tiny causing the error. Divisor is negative 1. Edge case for overflow. 2 to the 31 minus 1. Divisor, dividend. What am I missing now? Just show the lines I need to correct. Oh, move this line up before the absolute value. Okay. Oh, because we have to determine negative before that value. That's why. Once you turn it to absolutes, then this doesn't really matter. That's what it's saying. So the order of the way it's executed matters. That will turn it green. What? What? What is going on? What is negative dividend divisors? What is going on? You fix the negative, but the condition should check before converting this dividend to thing. You still have counter minus equals 1. Oh, where did I have that? Oh, this is probably ruining it. That's why. No matter what I have, it wouldn't be right. This is so dumb, bro. It's always some syntactical issue. You see what I'm saying? It's like the logic is perfectly the fucking same. You see that? This is the core logic of how to do division. Fit the value in the value you're targeting X amount of times. Get the counter for that value. That counter is your division value. Then you just have to adjust it for negative, positive. And then this other shit here is just the bounds. So it says your number can only be between this range, and if it's greater than that range, make it this number, right? But as you can see, everything I've done originally was perfectly sound that we did on the whiteboard, okay? So let's try submitting it. It's probably going to pass now because it now satisfies the condition of the bounds. Time limit exceeded. Okay, so this is what it's going to do where it says we have to use the shift bit registers. Because instead of going, because right now we're just incrementing one, fit this. So we're adding 3. If you have 10 million and you're dividing by 3, it's going to take forever, right? So we have to go shift bit register to get doubles, to get multiples, and you get the max multiple that'll fit. So let's do that. So we've solved the question at this point. Now we just have to do it within the time complexity. Inefficient for a range, yep, 10 to the 9 iterations. Doubling divisor, it's using bit shifting, which allows you to perform in logarithmic time instead of linear time. Okay, cool. So all this logic stays the exact same. All this stays the exact same. All we're doing now is instead of adding 3, we double it. 3 becomes 6, 6 becomes 12, 12 becomes thing. So that way, if we don't need to do all these incremental divisions, we just skip to the big chunks. You see what I'm saying? So now we go. While dividend is greater than or equal to divisor. So where is it? Yeah, this is where the magic happens. While dividend is greater than or equal to divisor. And then while dividend is greater than or equal to temp divisor, because we have to go dividend minus temp divisor to get encounter multiple. So the amount of times it'll fit in there. So instead of going 1, 2, 3, 4, we go logarithmic because it halves the time. Because we're doubling our divisor every time. Doubling the count. Temp divisor multiple. And then temp divisor is the divisor. 1 is the multiple. So every time we do that, we get a multiple by x. Let's see, multiple. And then while dividend and then we go temp divisor multiple. So it's shift bit register to 1. So every time you shift to the 1, it doubles. Because 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 4. Like all that shit. Okay, so then multiple 1, and then we go. I think it's outside of the loop we have to do that, yeah. So outside of this while loop, we have to do it. It's temp divisor. Oh, dividend minus equals temp divisor. Okay, so dividend minus equals temp divisor, and then multiple So counter plus equals multiple. Alright, I can get rid of x now because we're not adding any more to it. We're using the temp divisor within this loop directly. So now that we have everything, all we care about is the counter. So we feed in the exact same logic. This is all there to just check the counter. The dividend minus this doesn't really matter. This is just there to check that the dividend is greater than the divisor. Yeah. So now we go counter. Oh wait, counter is still the same logic. Invalid syntax. What is invalid? Temp multiple. Temp multiple. What is that? Temp multiple. Oh, temp divisor. I don't know why I put multiple there. Temp is not defined. Oh, temp divisor. Yeah, temp divisor. That's what we're going to be doubling every single time. Temp dividend. Temp divisor is not defined. Temp divisor. Oh, temp divisor. Divisor. Counter plus equals multiple. It's always some syntactical issue that gets me, man. Every single time it's like spelling or something dumb. You know, like it's not the logic that's like completely wrecked. It's always some sort of syntactical thing. So as you can see, passes all the submissions, passes all the temp cases. What we do here is instead of adding and going 3, 3, 3, 3, so 3, 6, 9, 12, 15, we go 3 times 2 is 6, times 2 is 12, times 2 is 24, times 2 is 48, times 2 is 96, times 2 is 192 or something. 9 times 2, 8, yeah. 180 plus 12, 192. So yeah, we do that because that way we can half the amount of time that we have to take to get to that result rather than like incrementally like this. 3, 6, 9, 12, 15, 18. So I'm doubling that result every time so I can get to the final answer a lot faster. And we use the shift bit register. Why do we use shift bit register? Because it's 2 to the power of thing. That's how we get doubles. And we do this because we can't use the multiplication operator, division, or mod, right? So this kind of forces us to use this because it's the only other way. So anytime it tells you you can't use your typical arithmetic operators, that's when you can kind of hint towards. It's like a hint towards using shift bit registers. Okay, so that's kind of, I guess, a rule of thumb. So yeah, if you like this video, please give it a thumbs up, subscribe, and comment below. Knologist out.